and we were drawing a picture with those because we had to do the top curve minus the bottom curve. What would happen if you flipped that and did the bottom one on top? You would get a negative answer. Now it should be the case that if you just did the absolute value of that, if everything else was correct, you should get the correct answer. So if you flipped them and got -3, then the true area should be +3. So that is a quick thing you can do on test or quiz. If you accidentally got a negative, go back and look. If all you did was flip them, you could run a negative through and fix it. But we had to know where they met, and we had to be able to do the top minus the bottom. So let's take a look at this one. First thing I need to do is figure out where these things are going to meet. So how can I do that? 7 equals 1. Sometimes I will tell you you're going to go from, x equals 2 to x equals 5, but if not, if I just want the area bounded by the curves, that's the area between them. So we have to figure out what makes them equal. So how am I going to find that? Is it going to be nice? No. Do we even have a technique for solving something like this by hand? We can multiply over the denominator. But is this helping? Are we going to find that? No. This is not a problem that I could put on your tests and quizzes unless I told you where they equal. But I wanted to talk about it. It's not always just a nice number where the two graphs meet. So we could use our calculator to find this. So everybody, you need a graphing calculator. Use your Chromebook if you don't have one. We did this last year. Sometimes when we needed to find intersection points in college algebra. You would go to your y equals, and we are going to graph both of these things. So the first one is x over the square root of x squared plus 1. And the second one, x to the 4th minus x. So there's my first curve. And there is my second one. If we need to, we could zoom in a little bit. Kind of see, so that's the x over the square root of x squared plus 1. X to the 4th minus x kind of looks like a parabola. So we are talking about this little region here. So obviously tests and quizzes, I'm going to give you nice ones that you can find the intersection, that we can draw the graphs by hand. But since we've got this, let's go ahead and just find these points. Can you guys tell what this point is? 0. And we should be able to check that pretty easily. If you plugged in 0, you get 0 for both of them. So that's the first one. So we are integrating from 0 to, we need to find the second one. So if you remember to do that, you can go to second, trace. We want where two curves meet, that is intersect, number 5. Then your calculator prompts you with some questions. All you have to do is hit enter because it will automatically go to the first curve. So first curve, just hit enter, second curve, hit enter. Guess you need to get close to the point we want. So we already know that first one is 0. Let's get closer to the second one. And it tells me it is approximately 1.18. It is not a nice answer, so we're just going to get ballpark values. Okay, so when I set this up, which one was on top? The x over the square root, so we have to do that one. Minus the bottom, which was my x to the 4th minus x. to split up this integral. I'm going to show you why in just a second. We know that if we're integrating, we can do individual pieces. I'm going to run my negative through. Okay, so I distributed my negative, and then I wrote my integral separately. Here's the reason. Can you integrate negative x to the fourth plus x? Absolutely, that's a polynomial. Is this one a nice polynomial for integration purposes? How am I going to integrate this one? Substitution. So I just split them up because I don't want more x's than I need in my substitution. I don't need it for these. Those terms are just added on, so I can integrate that part by itself. We need substitution to do this first one, though. So for that, you want to pick your u to be the inside, the first thing you would do, which is x squared plus 1. So du is 2x dx, which means 1/2 du replaces the x dx. Okay, so I'm really just going to do each of these separate. Alright, so for my u, let's go ahead and change the limits. If I put in 0, 0 squared plus 1 is 1. If I put in 1.18, 1.18 squared plus 1 is 2.3924. X dx is my 1/2 du. This would be 1 over the square root of u, or I could write that as u to the negative 1/2. So to integrate that, you add 1 to your power. Reciprocal goes in front, so that would be a 2 times the 1/2 that's already there, so those just disappear. Okay, so if I plug those in, get that beautiful decimal. Is that my final answer though? No, I still have to do the other piece. So we are doing this plus, now let's integrate that one. So the antiderivative of negative x to the fourth would be negative 1/5 x to the fifth. Antiderivative of x would be a 1/2 x squared. If I put in a 0, both of those are 0. So if we add those together, we get about 0.7854 approximately. So our areas don't have to turn out nice and pretty every time. I just wanted to give you one ugly example to show you that most of the ones I'm giving you are very carefully picked to turn out halfway decent. Any questions there? The next thing your book mentions is really what we've already talked about. We've set everyone up so it turned out to be positive, but really if you wanted, you could subtract those in any order as long as you do the absolute value of it. Just recognize that the area between those two curves has to be positive. So if you did ever get your negative, you could throw those absolute values on there and get the correct answer from that. Alright, let's do another slightly ugly one. So I want the area of the region bounded by the curves. Y equals sine of x, y equals cosine of x equals 0, and x equals pi over 2. Draw a picture. Do we know the starting and stopping points here? If I give you that x equals a number, those are just vertical lines. So x equals 0 is just here. X equals pi over 2 is here. So really those should be our starting and our stopping points. So I really only have to figure out what the graph looks like between those. Sine of x. So sine of 0 is 0. What's the sine of pi over 2, or the sine of 90? 1. So that curve, you could get more points, but it's really just a curve like that. Sine of 0 is 0 and sine of 90 is 1. If I looked at cosine, what's the cosine of 0? 1. And the cosine of 90? 0. So my cosine looks like this. Where do those things cross? Where are sine and cosine the same? Think about your hand trick. Sine and cosine are the same here. 45 degrees, which is pi over 4. If you just integrate this thing from 0 to pi over 2, you're going to get 0 for your answer. Because what happens is these two pieces, they flip. So if you just said from 0 to pi over 4 of sine x minus cosine x, you would get a positive and then a negative, and they're going to wash out. How do I have to set this up then? Two separate intervals, just like when we did absolute values. We had to find out what made the inside 0 and break it up there. Since these two curves do cross in the middle, we have to break it up. So we're going to go from 0 to the pi over 4, and then we'll go from the pi over 4 to pi over 2. Between 0 and pi over 4, which one was on top? Cosine. So we would do cosine x minus sine x dx. Between pi over 4 and pi over 2, which one's on top? Sine. So we'll do sine x minus cosine x. So if we integrate here, antiderivative of cosine is sine minus antiderivative of sine, negative cosine. So that becomes sine x plus cosine x from 0 to pi over 4. Plus, over here, antiderivative of sine, negative cosine, minus antiderivative of cosine is sine from pi over 4 to pi over 2. Okay, so sine of pi over 4, that's like sine of 45 degrees. That's radical 2 over 2. Cosine of pi over 4 is also radical 2 over 2. minus sine of 0 is 0 minus, sorry, plus cosine of 0 is 1. So that's the first one. Second one, cosine of pi over 2. So cosine of 90 degrees was 0 minus the sine of 90 is 1 minus negative cosine of pi over 4 would be negative radical 2 over 2 minus the sine of pi over 4 is radical 2 over 2. Have I lost anybody? What's radical 2 over 2 plus radical 2 over 2? It's like 1 radical 2 over 2 plus 1 radical 2 over 2 is 2 radical 2 over 2, which is just radical 2. Minus 0 plus 1 is 1, plus 0 minus 1 is negative 1. This would be negative radical 2, so minus the negative makes plus radical 2. So add like terms and we get 2 radical 2 minus 2. I know these two have been significantly uglier than the problems we did on Friday. Are there any questions about that? Let's look at this one. Find the area enclosed by the line y equals x minus 1 and the parabola y squared equals 2x plus 6. What do you want to do? How is this one different than the others? Yeah, I've got a y squared in here. If we wanted to graph y equals x minus 1, that's just a line. Y-intercept is negative 1, slope is 1. So up 1 over 1. It's a y squared. What's that going to look like? No. So if we don't know what it looks like, what can we do? Issue with the calculator, it has to be y equals before you plug it in the calculator, doesn't it? So you can do a square root and try to plug it in, but knowing that we don't have a calculator on the test, what if we kind of made a t-chart and see if we could figure it out? Usually t-charts are easier if you solve for one of your variables first, so it might be easiest here if we solve for the x. So let's pick our numbers for y. So if I put in a 0 for your y, 0 squared is 0, minus 6 would be negative 6, divided by 2 is negative 3. If I put in a 1, you get 1 minus 6, so negative 5 divided by 2. If I put in a 2, you get 4 minus 6, so negative 2 divided by 2 is negative 1. What happens if I put in a -2? You get -1 again. If you put in -1, you get the -5/2 again. So if I plot those, this is like a sideways parabola, which makes sense if x squared is like a normal parabola, so if it's y squared, it's a sideways parabola. All of our graphs so far, we have had a left-hand point and a right-hand point. But here's the issue. If I started over here at -3 and did my top curve minus the bottom curve, is there even an area contained between the curves then? No. And when I get over here to whatever this intersection is, then we've got all kinds of issues because there's some contained here and then some between the line and the bottom part of my parabola. So this one has all kinds of problems. However, if I extend my line out, could you tell me a top and a bottom intersection point on this one? Yeah. Sometimes, all the problems we've been doing, it's been easiest to integrate with respect to x. We kept x as our variable, so we had to do our left hand and our right hand. But sometimes it's easier to work with y's, which was kind of obvious if we look back when we had that y squared. We weren't just going to get y equals something in this problem. Or if we do, we're going to have to break it up and do a positive square root and a negative square root, and it's going to get very ugly. But it's not that hard to find what x equals. So this time, we are going to integrate with respect to y. We need to find out the points where these meet. Depending on how good your graph is, you might already know. But if I solve for x in both of these equations, then I have y plus 1 equals x, and we already did this one. Could you set those two equal to one another and solve? Yeah, let's do that. So I have y plus 1 equals y squared minus 6 over 2. So multiply over my 2. It's a quadratic, so set it equal to 0. So multiply -8, add to -2, which would be a -4 and a +2. So if we set those equal together to each other, or to 0, excuse me, we get y equals 4 and -2. So that tells me the y values where those curves meet. If I want to keep y as my variable, everything has to be a y. Both your upper and lower limits have to be y's. The variable in your equation has to be a y. It has to be a dy at the end. So either everything is an x or everything is a y. If we are doing with x, we go left to right, small to large. So with y's, small to large, we would do bottom to top. So we'll go from -2 to +4. Okay. Think about the others. We did the top minus the bottom because we wanted to get a positive answer. When you integrate with respect to y, you're going to have to do the right minus the left. So everything flips. Instead of thinking top to bottom, you're going right to left. So the curve on the right is the line which is y plus 1, minus the curve on the left is this parabola looking thing, which we are using y squared minus 6 over 2. Okay, we have kind of completely changed how we set those up. Are there questions so far? If we wanted to clean this up a bit, this would be a y plus 1. I could distribute a negative 1/2 through that, so that's negative 1/2 y squared plus 3. You could even add some like terms if you wanted. So I have a negative 1/2 y squared plus y plus 4. Okay, so if we do our antiderivatives, add 1 to the power, so we need a 1/3 to go in front. This would become y squared, so we put a 1/2 in front. Be a 4y. So I have a negative 1/6 times 4 cubed. That's 1/2 times 4 squared. That's 4 times 4. Minus negative 1/6 times negative 2 cubed. Plus 1/2 times negative 2 squared. Plus 4 times negative 2. Alright, this is one we could work out without a calculator, couldn't we? 4 to the third would be 64, so negative 64 over 6, or negative 32 over 3. Plus 16 times 1/2 would be 8, plus 16. Negative 8 times negative 1/6 would be a positive 8 over 6, so positive 4/3. Negative 2 squared is 4 times 1/2 is 2. So I get 30 minus 36 over 3 is 12. We get 18. Questions on that one? Let's try just some, the rest of them, there's nothing new, but I think we could probably use a little more practice. So let's just look at some of these others and practice setting them up. Now that sometimes we do it with x and sometimes we do it with y's. So find the area of the region bounded by the line y equals x and the parabola y equals 6 minus x squared. So am I going to do this one with x's or y's? Since you could do it either way, but since we can easily have what y equals, we can just keep x as our variable. We need to find out when they meet. So quadratic, set it equal to 0, so that would factor into x plus 3 and x minus 2. So we get negative 3 and positive 2. I do want a rough sketch here. If you put in negative 3 on your line, you're going to get negative 3, 2, 2. There's my line. This This one, you can plug in a few points. If you put in -3 squared is 9, so that's 6 minus 9 is -3. If you put in a 0, 6 minus 0 is 6. If I put in a 2, 6 minus 4 is 2. So we get this kind of parabola. Okay, so that's what I'm looking for. So since x is my variable, everything is an x. This is a dx. These are x values, which we have as -3 and 2. And when you're dealing with x, you do top minus bottom. So the top curve is the 6 minus x squared minus the bottom, which was just x. So this thing we can just do antiderivative. Antiderivative of 6 would be a 6x minus antiderivative of x squared, 1/3 x cubed. Antiderivative of x is 1/2 x squared. So if we plug in a 2, 6 times 2 is 12. 2 to the third, 8 over 3. 2 squared is 4 times 1/2 is 2. -3 to the third is -27 times -1/3 would be a positive 9. So we get 10 minus 8/3 plus 9 plus 9/2. So if you were on a test and you were trying to put all this together, you would have to get a common denominator. What would it be? 6. So if I took this one times 6 on top and bottom, you'd have to multiply by 2. This one by 3. Okay, so we get 125 over 6. I'm trying to take the time to show you guys how to work these out without a calculator in your hand. Questions? Probably only have time to do one more. Let's go ahead and do that. So in this one, do you think we will keep x or y for our variable? Probably a y, because there's a y squared. I don't really want to introduce radicals into my problem if I can avoid it, because then it's a lot harder to integrate. So this would be one where I would recommend keeping the y. Okay, y equals 1/2 x, that's just a line. Y-intercept of 0, slope 1/2. You might recognize from the last one, this is just going to be like a sideways parabola. You can always plug in some points if you need to graph it, or if we could go ahead and find the intersection and get that, use that to help us. We would need to solve for x on both of these, so this would be 2y equals x. This would be y squared minus 8 equals -x. So x is 8 minus y squared. So if you set those equal to each other, you get y squared plus 2y minus 8 equals 0. Multiply a negative 8 and add to positive 2. Get positive 4 and a negative 2. You know, if you plug those in, 8 minus 16 is negative 8, so this one meets at negative 4, negative 8. I'm just going to pretend that works. If you put a 2 in for your y, you get 8 minus 4, so that's 4. And of course, your pictures don't have to be that in depth, just something so you can tell how to set it up. You know, if I put in a 0 here, I get out my y is 0, my x is 8, so you have the point 80 on your graph, if that helps. And then I've got these 2 points, so that's probably enough for me to kind of see that this is parabola. It looks something like that. So we have to find this. Okay, if I'm keeping y as my variable, that means this is a dy at the end. These have to be y values. So you go bottom to top. And when you set it up, you do the right minus the left. And how will you know if you flip them and did it backwards? You'll get a negative at the end. So the right-hand curve, that was my parabola. So that's my 8 minus y squared. Minus the left was my line, which is the 2y. So we can integrate. Antiderivative of 8 would be an 8y. Antiderivative of y squared is 1/3 y cubed. Antiderivative of 2y would just be a y squared. So if we plug in, 8 times 2 would be 16. 2 to the third would be 8 thirds minus 4. Again, negative 4, that's negative 32. Plus 64 over 3 minus 16. Negative 36. Alright, that's everything. So most of the problems I'm giving you are fairly nice in terms of intersection points and the curves themselves, but we did look at some that were a little bit uglier today. I only have one example left. On Friday, I gave you problems 1, 2, and 13. So now we have the others. This will be due on Wednesday. So tomorrow will be a work day. I might work through that last example that we haven't done to start class. And then the rest of the time will be class time to work on the homework.